This is chapter P4, section 4, rational exponents and radicals, day 1. Radicals is when you have the square root of something. We call that a radical. If you have square root symbol without a number up here, that's the value of that radical is 2. If you have any other number up here, like a 3, that's called cube root, a 4 is fourth root, 5 is fifth root, etc. So there are numbers that go up here, but if you never ever see a number up here, that means square root, and that's the value up there is a 2. So if we have the square root of a equal to b, what that means is we started with b squared equals a. And if you think about how to solve that, b squared equals a, to solve for b, you would have to take the square root of both sides to get b equals the square root of a. And also in this consideration, b has to be greater than or equal to 0. When b is greater than or equal to 0, we call this the principal square root. So when you take the square root of a number and it's a positive answer, the b is equal to the square root of a, that is the principal square root. So I talked about having different values other than 2 up here, the square root. So we call that the nth root. So the nth root of a, if that is equal to b, well, that means we had b to the nth power with an exponent of n equal to a. And similarly, if you had b to the n or any other number, you have to use the appropriate radical value. So in this case, n represents any number, so we're going to take the nth root of both sides to solve that, and we would get b equals the nth root of a. So that's just the understanding of having those different values for your radicals. And again, if n is greater than or equal to 0, we aren't going to have negative numbers up there. And if n is an even number, we must have a greater than 0 and b greater than or equal to 0 as well. So greater than a is greater than or equal to 0 and b is greater than or equal to 0. And again, this is called the principal nth root. So for example, if you had the b cubed equals a, then you would say b is equal to the cube root of a by taking the cube root of both sides to get there, because the radical value cancels out the exponent and you get b equals the cube root of a. So that would be the principal cube root of b. If I had a number there, let's say I had x to the fourth is equal to 16, okay, you would take the fourth root of both sides, the fourth root, and that cancels out the exponent to leave you with x. And the fourth root of 16, because 16 is found by multiplying 2 times 2 times 2 times 2. There are 4 2's, that's 2 to the fourth. So really, you are taking the fourth root, if you want to think of it this way, the fourth root of 2 to the fourth. And because you're taking the same radical value as the exponent, those cancel each other out, so that x is equal to 2. And 2 is the principal fourth root of 16. So anyway, that's just some information about how that works. Let's look at properties of nth roots. If I have the nth root of 2 different variables being multiplied by each other, we can separate that out into the nth root of a times the nth root of b. Same thing with division. If I have the nth root of a divided by b, or a over b as a fraction, I can split that up and I have the nth root of a over the nth root of b. Similarly, if I had these two separated to begin with, I can combine them into one. Same with the division here, or the fraction. Number 3, if I have a radical and another radical, I can combine these two, kind of like we did with the exponents. I would multiply these two to get m times n. So the mth root of the nth root of a, you can take m times n as the radical value of a. Number four, if you have the nth root of a to the n, as I was speaking of over here in the red, those values cancel out and you're left with just a. Um, so if n is an odd number, you're just left with whatever value is in there. For example, if and the reason that this is important to understand, if I have the cube root of 8, okay, the cube root of 8, because 8 is 2 to the third power, the radicals cancel out, I'm left with 2. If I have the cube root of negative 8, that means I have the cube root of the negative value of 2 cubed, and the radicals cancel out. My answer would be negative 2. So whatever the actual value is underneath is the actual value of our answer. So if we started with positive, we end with positive. If we started with negative, we end with negative. That's if this value of the radical is an odd number. If the radical is an even number, our outcome is always going to be the absolute value of the number. With variables, we have to show the absolute value bars. So if I take the um, fourth root of x to the fourth, when these cancel out, I cannot just say x. I need to say absolute value of x. Because what if x was a negative number to start with? I need to make sure the outcome is a positive answer. Because when you take negative 2 to the fourth power, negative 2 to the fourth power is positive 16. If you take the if I take the fourth root of positive 16, that is 2, not negative 2. So I need to consider that and take that into account. And so for variables, I need to make sure I have the absolute value marked here. If I have numbers, it works out because I'm going to take that exponent usually and have a positive answer under there anyway. Okay? If you have more questions, just make sure you ask in class. Definition of nth root. Okay, if I have the nth root of a number or a variable, I can rewrite that into exponential format where the radical value becomes the denominator on the exponent. So right now, the exponent on a is 1. So if I have the nth root of a, or a to the first, then I can rewrite that without the radical as a to the 1 over n. So n becomes the denominator. If I have the exponential form, I can rewrite that in radical form by taking the number that's the denominator and putting it as the radical value. So just going backwards. Also, if I take the nth root of a to the m, whatever this exponent is, I have the n again going to the denominator. So here the m is an exponent inside the radical. If I have m outside of this radical value, it's the same. It's going to have the same result because if you take, if I think about a to the, let's see, the fifth root of a, and then out here I have a 3. Well, if I think about the inside here, using the definition of the nth root from the beginning here with a to the first, I could rewrite this as a to the 1 over 5. And then with the exponent of 3 on the outside, that's going to have to go in and multiply times that exponent anyway, and I get a to the 3/5. If I had the fifth root of a to the third to start with, this just becomes the denominator of whatever exponent is here. So we just take that and we rewrite it as a to the 3 and the denominator becomes 5, so 3/5. As you can see, I have the same answer as I did when the exponent was outside of parentheses. So that's what this is saying right here. Similarly, if I could work backwards, if I start with the variable with the exponent as a fraction, the denominator can become the radical value to rewrite that in radical form. And the m can be the exponent on the inside of the radical, or you could put the m on the outside of the radical with the parentheses like this. Okay, let's look at some examples. We want to write these into exponential notation. If we have an example here of 1 over the cube root of 7, I can rewrite that as 1 over 7 to the 1/3. And because that the exponent is in the denominator, I could write this without being a fraction as 7 to the negative 1/3. Looking at the second example, we need to make sure we apply the radical value, bring that over to the exponent here, and we're going to have that as a denominator on the exponent, so that's 2 to the 3/4. And that is our exponential format. And then when we go to this next example here, we have 1 over the square root of x cubed. The radical value on this square root is 2, so we're going to bring that over here to be the denominator. So we have 1 over, sorry about the bell, 1 over x to the 3/2. And then because this is in the denominator, we are going to write it as x to the negative 3/2. Okay, let's look at here. We need to evaluate the expression. This is number 10 on page 35 in the college algebra book. So the square root of 64, could just kind of like break this down a little bit. We could think about the square root of 64 as 8 squared. The fact that 64 is 8 squared. Then we know that the square root cancels out the 2 here, and we will get our answer of 8. When we have the sixth root of negative 64, we have, if we look at the value of negative 64, we can think about the breakdown of that. If I take 64, I have 2 times 32, and 32 is 2 times 16. 16 is 2 times 8. 8 is 2 times 4. 4 is 2 times 2. So that's 1, 2, 3, 4, 5, 6. Because my radical value is 6, that is going to work out perfectly. So I have 2 to the 6th. And that is really negative 2. So that if I think about 2 to the 6th, because this is an even exponent, technically my answer would, even if this was negative 2 to the 6th, that would be positive 64, but I need a negative 64 here. So I need a negative value of 2 to the 6th. And when I take the 6th root of that, then my exponents can cancel out, and my answer here would be negative 2. Oh, hold on a minute. Let me backtrack on that. I didn't think that sounded right because really you can't take this even radical value of a negative number. So this was supposed to be a 3 here. So the radical value on that was a 3. So really what I need is, instead of 2 to the 6th, I need um, an exponent of 3. So if I kind of group these together in pairs of 2's, then I have 4, because 2 times 2 is 4, and then 4 And 4, that would be 4 to the third. And so I have negative 4 to the third power. And when I take the third root of that, then now my radical and my exponent can cancel, and my final answer is negative 4. Sorry for the confusion on that. Part C is the fifth root of negative 32. So similarly, make a factor tree if you need to. When you break that down, you will get 2 to the fifth. With an odd exponent, negative 2 to the fifth is negative 32. So I get negative 2 to the fifth, and I'm taking the fifth root of that. The radical cancels out the exponent. I will get negative 2. And for this last example here, I have 1024 to the negative 0.1, which is 1/10. So 1024 to the negative 1/10. And because that's a negative exponent, let me make that a 10, I'm going to have 1 over 1024 to the positive 1/10. If I do a factor tree, I will get 2 to the 10th. I will get 10 2's like this. And this radical, or this exponential value, actually will then be the 10th root of 1024. So when I take the 10th root, knowing that 1024 is 2 to the 10th, I will get 1/2, because the 10th root of 1024 is 2. Example B, or part B, I'm going to have this to be the third root, because the denominator here is 3, so that's third root of 27, the negative value of 27 over 8. And my exponent on that is a 2. Then I can take the cube root of the fraction here. The cube root of 27 is 3. The cube root of 8 is 2. This negative is going to stay negative because we're talking about an odd value out here. And then we square this, and we will get this negative value, because the even exponent is going to become a positive answer. 3 squared is 9, and 2 squared is 4. And then same thing with this. We have a denominator of 2, so that's going to be the square root of 25 over 64. And then that's to the third power. I'm going to put it like this. The square root of 25 is 5. The square root of 64 is 8. And then my exponent of 3 is going to be 5 to the third over 8 to the third, to give me 125 over 512. And that's it.